Good morning students. In the previous video lecture we have discussed about electric field intensity due to point charge, and the final formula of the intensity is kq upon r square. Let us discuss something about electric field intensity due to point charge, which is useful for further topics. This is point charge plus q, and at a distance r a point p is present. This q charge is called source charge. Because of it is the source of electric field, it produces electric field around it. At point P, what is the magnitude of electric field intensity? kq upon r square. Similarly, my dear students, suppose this is minus q charge, which is source charge. Here the charge is positive plus q, here the charge is minus q, and at a distance r, a point P is present inside the electric field of minus q charge, where magnitude of electric field intensity will similar kq upon r square. Board level students actually have misconception. In the case of minus q charge, they write electric field intensity magnitude equals to minus kq upon r square. That is completely incorrect. My dear student, this plus q charge and in this minus q charge, if charge, magnitude of charge and distance are similar, then magnitude of intensity will similar. Actually, the negative sign affects the direction. In this case, at point P, direction of electric field intensity. In the previous lecture in special points we have discussed about it. Direction of electric field intensity is away from positive point charge. So at this point, away from positive point charge, and at this point P, towards the negative point charge. Clear? In the case of positive charge, direction will away from positive point charge, and in the case of negative point charge, direction will towards the negative point charge. Now come to the next topic, that is electric field intensity due to multiple charges system. Electric field intensity due to multiple charges system. Intensity due to multiple charges system. What is the electric field intensity due to multiple charges system? My dear students, my question is, suppose this is q1 point charge, this is q2 point charge, and this is qn point charge, and it is the XY reference system, Cartesian coordinate system, in which rectangular coordinate system, XY reference system. This is origin, has the coordinates 0, 0. My dear students, this q1 point charge has the position vector r1 vector. This q2 charge has the position vector q2 charge has the position vector r2 vector, and this qn charge has the position vector rn vector. My question is, what is the net electric field intensity at point P? This system is n charges system, poly charges system, multiple charges system. Why? Because of in this system there are n charges are present. If n equals to 5, it means there are 5 point charges. N equals to 10, there are 10 charges system. Clear? My question is, what is net electric field intensity at point P? How you calculate net intensity at point P? My dear students, in this case, you will find out electric field intensity individually, one by one. At first, we are finding electric field intensity due to q1 point charge, and let this position vector is actually position vector of point P with respect to q1 charge, which is represented rp1 vector, position vector of point P with respect to q1 charge. Come to the point. Electric field intensity at point P due to Q1 point charge. At point P due to Q1 point charge, electric field intensity E1 vector will equals to, tell me what is electric field intensity at point P? According to formula KQ upon R square. K in the place of capital Q charge, dear student, here the Q1 charge, K Q1 upon, and the distance is not R. In this case, distance is magnitude of RP1, magnitude of RP1 square. But my dear students, here we are writing vector form of electric field intensity, but this is only magnitude. You know, a vector never can be explained by only magnitude. You have to write direction. What about the direction of E1 vector? We have explained in above portion. Direction of electric field intensity due to positive charge is away from positive charge. So E1 will in this direction. Am I right or wrong? Away from positive charge. This E1 is along the direction of RP1 vector. So you will stick or you will write RP1 cap. This unit vector actually explains the direction of E1. Clear? This is electric field intensity due to Q1 point charge at point P. At this point P. Now find out electric field intensity due to Q2 charge. I am writing similarly. Electric field intensity due to Q2 charge. Tell me. Due to Q2 charge, suppose the position vector of this point P is RP2 vector. Tell me what is RP2 vector at first. RP2 vector is position vector of point P with respect to Q2 charge. Clear? Due to this point charge, electric field intensity will K Q2 upon magnitude of RP2 square, and dear students, again direction will away from positive charge in this direction. Actually this direction of E1 vector and this direction of E2 vector away from positive point charge. Tell me, this E2 vector is along RP2 vector, yes or no? So the direction will along RP2 cap. This unit vector explains the direction of E2 vector, which is equation second. My dear students, similarly for nth point charge, what about the electric field intensity? En vector will equals to, according to formula, what is the intensity? En vector will equals to K Qn upon position vector of point P with respect to this Q1 point charge will Rpn vector, and intensity will in this direction, that is En vector. Clear? Kqn upon Rpn vectors magnitude square. This is only magnitude, which is not correct expression for En vector. A vector quantity needs magnitude as well as direction. What about the direction? Direction of En vector is along Rpn cap. Rpn cap. This is the unit vector which explains the direction. This is equation third. My question is, what is the net electric field intensity of at point P? According to superposition principle, superposition principle, net electric field intensity at any point due to multiple charges system will equal to the vector sum of all individual electric field intensities at that point. Individual means you have to find out one by one. In the previous page we have find out at first electric field intensity due to Q1 charge, that is denoted by E1 vector, due to Q2 charge denoted by E2 vector, and finally due to Qn charge denoted by En vector. So according to superposition principle, the net electric field intensity at point P will equals to the vector sum of E1 vector plus E2 vector and so on up to En vector. Use all the values of E1 vector, E2 vector and En vector from equation first, second and third. The net intensity will become, what is E1 vector? E1 vector is KQ1 upon RP1 magnitude square RP1 cap. What is E2 vector? KQ2 upon RP2 magnitude square RP2 cap. And similarly, what is the final En vector? En vector is KQN upon RPN magnitude square RPN cap. Is it clear? Look at this expression. In each term K is common out. So K is common in each term. So it is taken common out K, and the remaining terms are Q1 upon magnitude of RP1 square RP1 cap plus Q2 upon magnitude of RP2 square RP2 cap and so on. Qn upon magnitude of Rpn vector square Rpn cap, which also can be write down in the summation form. E net is equals to K summation I equals to 1 to n, I is the variable, Qi upon magnitude of Rpi square Rpi cap. Some students cannot understand this simplified summation form. Dear students, I starts from 1 and finally goes up to n. Whenever you will use I equals to 1, the term will become Q1 upon Rp1 square Rp1 cap. If I is replaced by 1, this is first term. Then this summation sign actually operates plus addition. After it, the plus, and I will now become 2. At first you have selected 1, then it will selected 2. I will equals to 2, then the term will become Q2 upon Rp2 square Rp2 cap, the second term, and similarly the last term. Dear students, generally this expression not asked in the exams. Actually this is basic concept for the solution of numerical problems. Come to some numerical problems on the basis of superposition principle of electric field intensity. My first question is, example first. It is an equilateral triangle. You know what is equilateral triangle. Let this vertex is A, this vertex is B, and this vertex is C. At the vertex C, plus Q charge is present, and side length of the equilateral triangle is A. Find net electric field intensity at point A. Find net electric field intensity at point A or at vertex A. Tell me the concept at first. How you find out net electric field intensity at point A? At first you have to mind it, my dear students. At point A, electric field intensity will due to this plus Q charge and due to this plus Q charge. According to superposition principle, according to previous concept, we will find out one by one individually. At first due to plus Q charge, then due to this plus q charge, then we will add the vector sum of both intensities. That will final answer. Clear? My dear students, electric field intensity at point A. Electric field intensity at point A due to plus q charge, of vertex B, plus q charge of vertex B. What is electric field intensity at point A? EB vector will equals to, according to formula, K Q upon R square, but in the place of R the distance of point A from the plus q charge is A, so K Q upon A square. It is only magnitude. What about the direction? We have to write down direction also. Actually, due to plus q charge, direction will away from positive charge. Direction will away from positive charge. This is the direction of EB vector. Any confusion? So EB vector is along BA vector. Direction is along BA vector, means point B to point A. Similarly, electric field intensity due to plus q charge of vertex C, plus q charge of vertex C. What is the electric field intensity due to plus q charge of vertex C? Again, due to this point q, this point charge plus q at a distance small a, we have to find out intensity at point A. Again, we will use electric field intensity formula due to point charge, that is kq upon r square. Let this intensity is EC vector, which will equals to k, the point charge is q, but now distance is not r. In the place of r square, you will use a square. It is only magnitude. What about the direction? Direction, again we have discussed about the direction. Direction will away from positive point charge. At this point, direction will away from positive point charge, that is EA vector. Direction is along CA vector. Dear student, if you mention vector form, you have to write down direction. This is magnitude kq upon a square, kq upon a square. From this equation first, from this equation second, the conclusion is out, and that conclusion is magnitude of EB vector is equals to magnitude of EC vector. Am I right or wrong? Magnitude of EB vector is equals to magnitude of EC vector. EB also has magnitude kq upon a square, and EC also has magnitude kq upon a square. Hence, net electric field intensity at point A. Net electric field intensity at point A. What will be the net electric field intensity at point A? In the previous section, we have discussed at point A, net intensity will vector sum of EA vector plus EB vector plus EC vector. EB vector plus EC vector will equal to vector sum. Vector sum of both EB vector plus EC vector. Any problem? This is net electric field intensity. This net electric field intensity also has both magnitude as well as direction. Magnitude as well as direction. At first we will find out magnitude, then we will find out direction. What about the magnitude? For magnitude, we need a formula. In the 11th standard, you have studied about if these are two vectors, a vector, b vector, and angle both them is theta, then r vector is equals to a vector plus b vector, then magnitude of r, magnitude of resultant vector is under root a square plus b square plus 2ab cos theta. Magnitude of R is under root a square plus b square plus 2ab cos theta. Similarly, in this situation, if you want to find out magnitude of E net vector, then magnitude of E net vector will become under root EB square plus EC square plus 2EB EC cos theta. And you know magnitude of EB is equals to EC and theta is 60 degree. Why the angle theta is 60 degree? Please focus. Because of it is an equilateral triangle, and equilateral triangle has each angle 60 degree. So this angle will also 60, this angle will also 60. So vertically opposite angle will equals to 60. What is the angle between EB vector and EC vector? 60 degree. If you will use angle 60 degree, then E net vector will have magnitude equals to under root EB square plus EB square plus 2EB EB cos 60, and cos 60 has the value 1 by 2. You know why EC square is replaced by EB square? Dear students, focus here. Magnitude of EB is equals to magnitude of EC. So EC can be replaced by EB. Now the magnitude of E net will equals to under root 2EB square plus cos 60 has value 1 by 2, 2EB square into 1 by 2, 2 cancel out. So finally the magnitude of E net vector will equals to root 3EB, that is root 3. And what is EB? EB is the magnitude KQ upon A square. This is the magnitude of electric field intensity at point A. But according to question, we have to find out electric field intensity, not only magnitude, electric field intensity. It means you have to explain magnitude as well as direction. This is all about the magnitude. All about the magnitude. What about the direction? Actually, my dear students, in the 11th standard you have studied about it in vector. If two vectors, A vector and B vector, both are same in magnitude, then their resultant vector actually bisects the angle both them. Their resultant vector, which occurs from addition, R vector, bisects the angle between A vector and B vector. Similar is here. Actually, EA vector, EB vector and EC vector both are same in magnitude, so E net vector will bisect the angle which pass in between from these. So direction of E net vector will in such a way that it bisects the angle between EB vector and EC vector. EB vector and EC vector. Clear? It is the first numerical problem. Dear student, this solution of this question is according to board exams, RBSE board exams. Clear? You can write down the solution directly, that angle both them is 60 degree. In the single line you can write down the answer of this problem, but according to board exam you have to explain all the things, what is the magnitude, what is the direction. Clear? Now come to the next example. Generally in 1 marks this question is asked in frequently asked in RBSE exam, board exam. Come to the second example. Suppose students, this is plus q charge, this is minus q charge, distance both them is 2a, it is midpoint O. Find net electric field intensity. Find net electric field intensity intensity at the midpoint O of the electric dipole. Actually, what is electric dipole we will discuss in next portion, last portion of the chapter. Directly you have to understand that you have finally find out electric field intensity at midpoint O. Clear? How you will find out electric field intensity at point O? Tell me what is the sequence, what will be the concept we have discussed. Superposition principle. At point O we directly not know any formula due to these point charges, but due to this point charge we can find out electric field intensity at point O, and due to this point charge we can find out. Please tell me what is the intensity due to plus Q charge. Suppose at point O intensity is E1 and this E1 will away from positive point charge. Yes or no? Due to this plus Q charge, intensity will away from positive point charge will in this direction, and due to minus Q charge, let the intensity is E2. E2 will towards the minus Q charge. Very important. Generally students give the answer directly. The intensity at the midpoint is 0, which is misconception, wrong concept. Dear students, intensity is a vector quantity, and due to plus Q charge, intensity will away from positive point charge, and due to minus Q charge, intensity will towards the minus Q charge. It means at point O, intensity due to both plus Q charge and minus Q charge is in same direction or opposite direction? Same direction. So my dear students, net electric field intensity at point P, net electric field intensity at point O. Dear students, the net intensity will equals to vector sum of E1 plus E2. But you know, if both these are in the same direction, then magnitude will directly equal to the sum of E1 plus E2. Why? Again I will say you in the junior standard you have discussed about this thing. If this is any body and this body experiences 10 Newton force in this direction, 5 Newton force in this direction, then what is the net force experienced by the body? Whenever two vectors are working in the same direction, the net is directly occur from their addition. 10 Newton plus 5 Newton, net force is 15 Newton. Similar happens here. E1 vector and E2 vector, intensity due to plus Q charge, intensity due to minus Q charge, both are in the same direction. Yes or no? Both are in same direction, then net magnitude of net intensity will directly occur from their algebraic sum, E1 plus E2. So E net will equals to, what is E1? KQ, and distance, this is total 2A, then the distance of midpoint from the plus Q charge will A, so KQ upon A square, and again KQ upon A square due to minus Q charge. Some students write the magnitude minus KQ upon A square. Dear students, magnitude due to this minus Q charge will also KQ upon A square. Actually this minus sign affects the direction. Due to plus Q charge, direction is away from positive point charge, and due to minus Q charge, direction is towards the negative charge. In the starting of chapter, this video lecture, we have discussed about it. Actually, negative sign not affects the magnitude. Magnitude will not minus KQ upon R square. Intensity not a scalar quantity that magnitude is minus KQ upon R square. In this situation, minus affects the direction which we have taken towards the negative point charge. Clear? So, the magnitude of net electric field intensity will become 2KQ upon A square. And what about the direction? Direction E1 and E2 both are in the same direction, so their vector addition will also in this direction. Suppose this point A, this point B, so direction at point O will along A2O vector. Direction will along AO vector. Yes or no? A2O. You can write down OB vector, O2B. You can write down AB vector along the direction A to B. That is your method. Now dear students, come to the next problem, which is homework for you. Next problem, homework for you. You have to solve it. This is a square of side length A. Square of side length A. Here the plus 2q charge. Here the plus q charge. Here minus 2q charge. Here minus q charge. This is the centrope square point O. Find net electric field intensity at point O. Find net electric field intensity at point O. This question is homework for you. Solve it. If any problem, I will provide answer of this question in the PDF. Okay. Thank you.